present a system to you today that we've developed. Now, our company is called Ferra Asset Management. Our client typically is a financial institution, and we used to build models. So we would, for a bank, for example, for the Cillian, we built some trading models, and they used that to trade futures. And for Eskom, we built models to project our consumption of the key customers were and things like that. But I've done both sides of the fence. All the models that I mentioned to you now, we developed in-house our own software to implement those models because we couldn't get it. It's typically a specialized thing where it's a general model that you want to do something special with. And so I've really been both sides of the fence. I've been modeling, and I've also been developing software for models. Okay, so what's the problem? The problem I'm looking at today. I'm looking at the problem from a central bank perspective. That does not mean the problem is unique to a central bank. The problem is fairly typical, but I'm gonna address it as if I'm a central bank. The problem for central banks is monetary policy. They need to make strategic decisions. They need to set interest rates, and there's a fixed calendar published a long time in advance. So at fixed times they need to meet, evaluate the output of the models, and make a decision. And that is the most important function of a central bank. They don't have a more important function than that. It's possible for a central bank to outsource their payment system, as they often do. They can outsource statistics, as some of them do. They can outsource, primary dealers, all sorts of things. But they cannot outsource monetary policy. They have to make those decisions and be responsible for them. So, I mean, I can sit in a wheelchair and have a robotic arm, but I need my brain. Cannot do that. So, if you look at the monetary policy committee cycle, I use a lot of central banking terms. This is the meeting that sits and makes the decision once every couple of months. The calendar is published years in advance, and the most important support function to the MPC is the modeling unit. Okay, so the modeling unit, I've just jotted down here my own thoughts if you want, but they need to continuously churn out and present credible and standardized reports containing dynamic results, serving ever-changing requests with fixed immovable deadlines, originating from a diverse and sophisticated suite of models on an ever-changing set of data that must retain integrity and maintain and utilize an archive of all past results. They have to produce, but the world keeps on changing. One MPC cycle, they might be tasked with, let's say, oil price alternatives. Let's say there's an energy crisis. Another one may be the rand weakness, so they need to prepare rand alternatives, but still retain the oil price alternatives, and so on. The monetary policy cycle is 2 years. The decisions you make now have the impact 2 years from now. So 2 years from now, you need to be able to refer back to the environment then and see what went wrong if there's a huge mistake. So it's actually a huge problem. I'll show you now how this is typically solved. But there are other cycles in a central bank: monetary policy review, the bulletin publication. Other places too: National Treasury, SARS, Stats Aid, and so on. Municipalities, policymakers, large enterprises have to continuously make good strategic decisions based on forecast, models, analysis, and so on. These are all the people that are involved in the exercise. Now I've got 2 slides here. Let me show you the next one. These 2 slides are the heart of the whole thing. Once I'm done with them, I'm going to zip through the rest. But this is what it's all about. So this guy, maybe he's working with data. That guy is external to the bank. It's maybe an external bank or some party that reports to the central bank, or he reports to somebody in the central bank. So either he has access to the systems, or he sends a letter or mail or something. This guy maybe is building models using Excel, let's say. That guy's building models, let's say, using MATLAB. This guy is preparing a presentation on PowerPoint. That guy maybe uses Word. But you have all these people that need to collaborate using these very powerful but very general applications. So this guy, let's say, is using Excel or a database. This guy is using PowerPoint. That guy is using MATLAB. So you have this huge integration problem. You are passing data around in this environment, and it's very easy to affect the integrity of the data as you convert it between the applications. And it's also important, you must use the most recent data. You can't rock up at the MPC with outdated information or wrong information. And the information changes at the last minute. At the last minute, something changes there, and there's 20 models that need to update, and on top of those 20 models are 10 other models that also have to reflect the changes. And this is the solution that I'll be showing you today. I need to go back to the problem just. So here you have the network or the mainframe in the middle, and all of these guys, the other pass files around on the network, or maybe there's a mainframe or a database that they use for time series, for example. Here, in the middle, you have something called JCMem, Java Trusted Memory. It's almost like a cloud solution, and everybody accesses that. Another way is with this, which is called JC Mod, Java Trusted Modeling. And that width, if you want, represents the functionality. So all of the functionality that the guys need, you try to put into one system, single system. They use that for data, for modeling, for reports, for presentation, for archive. The external guys connect to that. And if you notice there's something happening on the outside that they regularly use, you try to bring that functionality into the system. They still use external systems. This guy maybe needs a report outside, or there's data outside, or maybe this guy's using some fancy modeling package for some specific models. But the moment it becomes part of the MPC cycle, it must be in the system. And it must be part of that. And then you have a lot of standardization. It's very easy for people to move between units or sections in the same unit. It's easy to standardize. Many of the data issues are addressed in this way. Okay, so first of all, JCMem, that stands for Java Clustered Memory. Now, cluster here means in the basement of the bank there's a bunch of machines, all more or less the same specs. It's a very homogeneous environment. You could, however, use a commodity cluster, and then this would be a cloud. So it could be a cloud as well. But be that as it may, in the basement you have a bunch of machines on top of which this runs, and if capacity is depleted, you just add more machines. It's very easy to increase capacity, it's very secure, and it's fast. It's always independent. You can, if you want, you can put a bunch of PlayStations in the basement. But it runs on Windows, Unix, Apple, anything that accommodates Java. And there's no external dependency, meaning there's no library. If you upgrade, there's no dependency on some third-party library that could trip you in the future. Okay, so that's the core. This is used for storage, for access control. It's used for some of this is exposed to the outside for outside participation. Next component is the web interface. It seems the whole world is moving towards tablets, so this is a way to get there. But it's also to some extent this is proof of concept. I'll show you this, but it's highly customer specific. So every client will have a different need for this. And then the big one for today is the modeling client. This is the front end that gives you access to the repository. Very easy to install. It runs on Java, so you can run it on Apple or Unix or Linux or Windows or PlayStation if you must. And a lot of modeling functionality. Some of these models are really cutting edge models, especially in the central bank space. But also, if you look at the world of econometrics, it sort of reinvents itself 5 to 10 years, every 5 to 10 years. So 5 to 10 years from now, the central bank's going to use models that's not yet invented. So it's a dynamic environment, and the idea is to grow this, keep on growing this. But again, I almost feel sorry for those guys, because the guy studied economics and econometrics, and then he's hit from Europe somewhere with this fancy new technique that makes use of linear algebra. That, there were textbooks for that somewhere, but that's about it. So you try to implement that in a way that makes sense to him, in a way that makes the model work in that environment, in a way that allows him also to control it, to manage it. So you want some output that he knows he can calibrate and change and so on. Also, around the modeling, of course, you need data functionality, you need reporting, you need to be able to collaborate your efforts, and so on. This one is highly customized, and I keep on saying it's highly customized for a central bank environment. The reason for that, we'll just go back a few slides. These applications aren't customized. You have a general purpose Excel or Word or MATLAB or something like that. Those things are powerful. You can do almost anything with it. But that power comes at a price. It's not customized. It doesn't do things the way you want it to do. Or you can, but then you need this huge configuration exercise, and that typically leads to a dependency on some person that understands that configuration. To try to take all of that away and give the guy something that already works the way he wants it to work, that already understands and integrates well into his